Hi class, in this video we're going to prove the quotient rule. Now they do mention in the instructions on the handout to use the function notation. That's just to make it easier for us to visualize the actual way that the function is defined. Now what I'm going to do is I'm just going to pick this notation, but I'm going to define the ratio of those two equaling to another function. So I'm just going to say let p of x equal to technically the ratio of f of x over g of x, and p of x is defined over the real numbers And what's important here is that technically the function g of x is not equal to 0. So we don't want any situations where you have the function undefined, meaning it's defined everywhere except we're specifically saying that, well, your denominators are not equal to 0, because then you're not gonna have you're not gonna be able to evaluate the derivative. So in this case, I'm just going to apply the definition, and we're going back to the original definition. In this case, f prime of x, I'm just going to define it as p prime of x using the notation that I started with. So in this case, the values of p prime of x is equal to the limit as h approaches 0 of the following mess. Now, at this point, I do want to use the way that we rewrote the functions. So we're going to have on the top f of x plus h over the values of g of x plus h minus the actual quantity of f of x over the values of g of x, and technically all over h. Now, the next step in the process is let's try to simplify our function. And in this case, what I'm going to do is I'm going to use an LCD. And your LCD is equal to, well, technically the two values in the denominator. So this will be g of x plus h, and technically g of x. So we're going to multiply top and bottom by that quantity. So this is g of x plus h times g of x, and at the bottom g of x plus h times g of x. Now keep in mind that on the top they're gonna multiply both of these terms. Nothing really happens in the denominator, so your denominator is just gonna carry that factor. So let me rewrite it. And we're looking at, this is equivalent to the actual limit as h approaches 0 of the following quantity, and as you multiply the LCD times the first function, your g of x plus h cancels, and we're left with f of x plus h times the values of g of x minus f of x times, and your g of x cancel, so you're left with g of x plus h, and technically all over the values of h times g of x plus h times g of x. In parentheses there, let me just put in a times here. Now, the next step in the process, it's technically to rewrite the ratio of these functions in a format that you could use some sort of a substitution or rewrite the problem so that you don't have the h here at the bottom. Because the way that we have it, if we technically evaluate h, then it's undefined. There's also no h's on the top that will cancel with that one. So the trick here is going to be to multiply by 1 over h, and technically 1 over h. So we're technically unsimplifying in order to rewrite that h in the numerator so that, well, basically we can use the limit and then rewrite our answer in this sort of a form. So it's going to go to the top. As you multiply to the top, I'm going to put the h's with the function that has the x plus h and x plus h. And then also at the bottom, the h's technically cancel, but they just go to the top. So I'm going to rewrite it in this form. This is still equivalent to the actual limit as h approaches 0 of, and I'm going to rewrite g of x first times f of x plus h over the values of h minus f of x times g of x plus h over the values of h. And then at the bottom, we technically have just g of x plus h times g of x. And let me double check there's no typos. So h goes to the top on the f's, that's this one here. H goes to the bottom of the x plus h, that's this one here. And then at the bottom, technically it cancels. Notice that this step is actually valid because we're just expressing the h on the top in an unsimplified form. And at this point, it's technically done. What I'm going to do is I'm going to use the rules of limits and technically distribute the limit to the top and bottom. And then I'm going to actually place it in between the f of x plus h over h. So we can use that definition. That is technically a derivative. And that's going to give us this portion here, f prime and g prime. So at this point, let me rewrite the problem, but let me go to the second page. And I'm just going to rewrite it as, we still have, technically that's p prime of x. So p prime of x is equal to, and the way that I'm rewriting it is technically g of x times the limit as h approaches 0 of technically f of x plus h over h minus f of x times the limit as h approaches 0 of technically g of x plus h over h. And then at the bottom, we do have that this is the limit as h approaches 0 of g of x plus h times g of x. Now at this point, I'm just going to put a disclaimer and do a substitution. So notice technically f prime of x is equal to the limit as h approaches 0 of f of x plus h over h, and also g prime of x is equal to the actual limit as h approaches 0 of g of x plus h over h. And then also as the limit approaches h goes to 0 for g of x plus h, this is just g times x plus 0 or g of x. So technically this function doesn't go to 0, it goes to g of x. So this allows us to rewrite it in the following form, which is technically our main answer, and this proves the quotient rule. So you have that p prime of x is equal to g of x times f prime of x minus f of x times g prime of x. And at the bottom, we have a g of x times another g of x, or g of x technically quantity squared, provided that g of x is not equal to 0. This actually proves the statement, and we now have shown that this formula is technically valid. This is just the alternative formula using use and dVs, but that is actually it for this one. We do have to define technically the ratio of f and g as some other function. And then what's important here is that technically they're any real numbers, but you cannot have 0 at the bottom, otherwise the actual derivative is not defined. In terms of disclaimers, we are multiplying by 1 over h or dividing by h, so h cannot equal 0. I'm just going to add that there, and then also add it at the end. I'll just say, and technically h cannot equal to 0. That's actually it for this problem. It did become a little bit messy, but overall, I mean, at least we can check here that the formula is valid. That's actually it for this problem.